Hello, thank you so much for tuning in for this presentation. I will talk about cultural change. Let's get started. The world we live in today is incredibly complex. It's complex both in terms of the information that seems to be doubling every 12 hours, if not faster, misinformation, but also various geopolitical and ecological crises that we are facing. Given these observations, in times like this, one key question is, how do psychologists and other social scientists explain and predict cultural change? And this is the topic of my keynote today. I would like to start by starting with a few examples of cultural change, how it has been studied recently. And next, I will share some insights from several initiatives my colleagues and I started over the pandemic that focus on how scientists have communicated their judgments about cultural change, what predictions they made, and how accurate those judgments have been. At the end, I hope we can discuss some ways to move forward. Typically, when we think of culture, we often think of some domains. And for this crowd, the example of individualism and collectivism, which are often used hand in hand, though not necessarily so, is probably very familiar. Not only since the seminal paper by Hazel Marcus and Shinobu Kitayama, with the probably very familiar circles that you see on this slide, but also other observations that have emerged before that, and in fact can go back all the way back to works by Ferdinand Tunis, if not earlier. I'm sure in ancient Greece we can find some writings describing some groups that are more socially attuned and other groups that are more individualistic, more Gesellschaft-oriented, as Ferdinand Tunis has described it. That there are also differences within what seems to be the same community, the same larger scale culture, the same society, between different generations. And some of those differences are attributed to changes in culture. So the question is, where and why do these differences emerge? And cross-cultural psychologists have been making a lot of possible explanations for the differences. And when we try to explain the differences, we often try to explain how culture evolves and changes. One example where we have done it in my lab was to look at the archival data from 78 countries covering around 50 years, aggregated the data from the World Value Surveys and National Census data to get composites of individualist values and practices. For values, we could use items that tapped into the importance of friends and family, the importance of teaching independence to children, and the value of self-expression. For practices, we can look at behaviors like having a smaller family, living alone in old age, as opposed to living with children and grandchildren. So here we would, of course, cheat a little bit. We would look at uniqueness, features, and also something that's actually more about collectivism rather than individualism. Though my claim is that on the societal level, those differences may not necessarily correspond to orthogonality between individualist and collectivist tendencies on the individual level. So if we do that and aggregate those measures and see that they actually hang well together, we would observe several things. These are the standardized scores across scores for practices and for values in different societies. So what do you see here? We see a huge heterogeneity across societies. So cultural change is never the same around the world, which is obvious. But we also see the general trend towards a greater individualism, both in terms of the practice and in terms of values. And there are some outliers. Yes, China is in red here on the graph. But that is partially due to only a few data points. And in fact, some other work suggests that the picture in China may be much more complex. So it seems like the trends are systematic. What could be driving this shift? And here, I just want to point out, for individualism, which is our favorite pet topic in cross-cultural research, we have lots of different explanations. In fact, some of the same scholars sometimes propose different explanations for what may be driving individualism. It is about abundance and scarcity, climatic stressors, as Harry Trans at some point pointed out, something about competition in dense urban environments, and that our societies move towards more urbanized environments. Something about pathogens, something that we have discussed more recently, of course, because of the pandemic. And what's important is that for each of this, nowadays, we can look at some quantitative markers. And if we do that, a very different picture emerges compared to when we just compare different societies and correlate their trends, group differences in individualism to group differences in, let's say, pathogen prevalence. A very different picture emerges because it turns out that only socioeconomic shifts seem to be corresponding, going hand in hand with shifts towards individualism. Sometimes, depending on the data, in fact, precede those, whereas other domains, not so much. They are unrelated or go in different direction. So this is just one example of how explanations and cultural change has been recently studied. And there is another way to look at cultural change and approach the topic. And I just want to briefly mention it. We can also look at the change in meaning. And this is the work that my colleagues Alan Choi, Norman Farb, and others have recently published in Clinical Psychological Review. The premise of this research was to examine the veracity of the mindfulness criticism. The original idea of mindfulness is supposed to be about engagement with the environment, greater awareness of your surrounding and others, as well as an acceptance of possibly less pleasant feelings. But some critics suggest that it has been corrupted. This concept of mindfulness has been corrupted by possibly industry and has now has been skewed towards avoidance and relief of suffering. So I wanted to test this question with my colleagues, and in the first part of the paper that I really encourage you to check out, we looked at the Google Books in English language. We tried to localize it specifically for English cultural change because this criticism applies to Western concept of mindfulness. And we wanted to reduce the scope and look at the dependencies. That is, I had the idea to look at how the term mindfulness may be related to other nouns in the same sentence, irrespective of words in between. So for instance, I could say awareness for mindfulness, and awareness is an essential element of mindfulness. And through a probabilistic process of dependencies, we can look at that. So on the y-axis here, you will see the percentage of dependencies in the corpus relative to all words in the corpus published in the same year. And now take a look what you see. What you see is that top words that emerge actually over the time have mostly dealt with engagement and awareness. So terms like awareness, terms like concentration, and so on. And there are not a single term among the top 10 indicators, top 10 words that co-occur with the term mindfulness that reflect something like avoidance or stress relief. You also see some changes. You see that over the course of the last 40 years, in the last 10 years, whereas at the beginning, awareness has been dominant as well as concentration, most recently, more practically oriented terms such as practice and meditation became more popular, as well as the idea of mindfulness trait. Okay, so that's just one way to study it. So basically, this criticism of mindfulness doesn't seem to be justified, at least in terms of the linguistic analysis of English language. And by the way, we also use some other databases to cross-check it. But there are some very legitimate points that critics actually making, and I encourage you to check out that paper in Clinical Psychological Review. Okay, so far I talked about explanation, just to give you a little bit of a sense of how we can study cultural change, how it has been studied recently. But when we talk about cultural change in psychology, and when we talk about, you study cultural differences, and then a friend comes to you and says, oh, that's really interesting, but there is this ongoing pandemic, and can you tell me how a society may be changing? And the reason why this friend may come to you is because over the course of the last 2 years, various newspapers and pundits have been making all sorts of predictions. And you just can't stop as a normal human being to think and worry about the future. And if you're like me, you probably did think about what may be happening next. And indeed, some of our colleagues even published very early on in the pandemic certain recommendations of what we should do because of certain threats for our societies. What's really humorous is that not only did we make suggestions and the news has reached out to us, the media, to ask us for recommendations, what may be happening next. Some of us made some quite interesting claims. For instance, here's a famous neuroscientist, Carl Friston. And in this early spring 2020 report, the interview that he had with a British newspaper, he said something like this: whether you're talking about the pandemic or brain, the essential problem is the same. You're trying to understand the complex system that changes over time. In that sense, I'm not doing anything new, just another day in the office. And what he referred to is that he basically has a system that can predict a pandemic, and he just used this system that he used for predicting brain functioning. And now he just, with some minor tweaks, can now apply it to the societal level. So there's certain interesting and, to my knowledge, puzzling claims that are in here. First of all, he equates explanation, his explanatory models, with prediction, potentially. But more importantly, he applies something that he may have learned about one level of analysis to a completely different level of analysis, namely of the society. And I'll return to this later. Now, why is explanation and prediction interlinked? And why am I even talking about prediction? Look, the mission of social science, including cross-cultural research, is to some extent to describe and explain social phenomena and behavior. I don't think it's a controversial claim. But what is sometimes omitted from it is that this has a certain purpose. Namely, we develop causal models of behavior. And if we develop causal models of behavior, if this, then that, it means that we need to test those causal models. And that's where the prediction comes in. I would argue that not only me, but also many other folks that you see citations for on the bottom, that testing causal models requires examining prediction accuracy. And here, of course, we can look at the internal testing using exactly the same formula, applying it to, let's say, a new sample, and examining then whether the same things that you initially predicted with a causal model would emerge. That's something that we call replication. And we can also test the external validity, so-called out-of-sample prediction, where you don't just focus on exactly the same sample or exactly the same type of procedure, but you apply it and try to generalize in a new sample. That's where cross-cultural researchers have initially emerged. We were interested if particular phenomena studied in one group can generalize to another group, because otherwise, how can we make any claims about universality of certain psychological processes? Now, one thing that I find is really important is that we have to distinguish between out-of-sample prediction that is based on past observation. So, for instance, if you just take a data set, you split it, a very large data set, split it into multiple pieces, and then you make predictions for this new bit based on the model that you developed on the other parts of the data. Or maybe you have collected data and you don't know what has happened, but you give people time series for something that happened earlier and ask them to make predictions for what happened later. But now you already know what happened because it's retrospect. You already have collected the data. Now, I like those approaches. I have nothing against them, except that there is a difference between this type of prediction and predicting future events, or so-called ex-ante events. And the reason there is a difference its difference is fundamental, is that when you make future predictions, for instance, consider stock prices. If you make predictions for the past, you may be operating using the same principles as making predictions for the future. But at the same time, other phenomena that have happened in the past, you are aware of, and it's very hard for becoming an amnesiac and forget about wars, bubbles, black swans, general trends in the economy, consumption trends, and so on. And so post hoc, predictors. Look, you would have access to this temporal variance in those events, occurrence for each of these variables, and you're much more likely to be successful. Whereas for ex-ante predictions, that's not necessarily the case. And in that sense, predictions about the past end up being more about testing, validity of people's explanations rather than testing their predictions based on the causal models per se. So I would really like to emphasize that it's important to focus on ex-ante predictions. So using this insight, I was wondering first, did psychological scientists, including cross-cultural researchers, talk about cultural change over the course of the pandemic? Or did only pundits and newspapers do so? And I'm interested in this because I want to know, to what extent do we go out beyond our comfort zone and make any predictions? I also want to know it because whenever I mention the idea of prediction to my colleagues, some of them would then say, I would never dare to make any predictions. No true social or cross-cultural researcher would go outside of their comfort zone or limits of knowledge and would make predictions for a domain that they know little about. And generally, we only study explanations. We try to understand mechanisms. We would never dare. I would never respond to that reporter who asked me to make predictions. So I was like, okay, interesting. How many are there like you versus how many would go on record and make predictions? And this is a project that I did together with a number of scientists, brilliant colleagues, led by Sandry Hutcherson's the lead author on this, as well as my student, Konstantin Sharpinsky. But there are many other people involved. So to address this question, we looked at the corpus of English language news, which has been looking through a web crawling algorithm on a random sample of news reports every couple of days from all over the world. It's a huge database by now. And when COVID started, they created a subset that looked specifically at news that mention COVID-related terms. And then we can look in this database for newspaper reports that mention scientists, particularly social behavioral scientists, which is what we did. We would localize it to the beginning of the pandemic. And subsequently, after we cross-validate credentials of each single member of the scientific community who was mentioned in this corpus, we end up with 169 articles, quoting over 200 behavioral social scientists. Some of them highly prestigious distinguished academics. So overall, we ended up with over 700 judgments made by the scholars in these newspaper reports and op-eds, and many of them were op-eds. And then we had independent coders examine whether the person was an expert on the topic that they are talking about, whether there's a match, whether they were just stating that what's happening or making a prediction, whether they provided any particular justification for that prediction. And we looked at the uncertainty in the language. So let's have a look at the results. So it turns out that every third judgment involved a prediction how society will change. And half of the judgments were made without any justification, suggesting reliance on intuitions rather than reference to specific research findings. Now, you may say, like, well, maybe newspapers just cut out those boring clarifiers, and maybe it's much more appealing if a scientist just makes off-the-cuff claims instead of justifies them by using data because that's longer, et cetera, et cetera. But keep in mind that we are talking about fairly established newspapers such as New York Times, Washington Post, and many op-eds where the scientist writes and provides a narrative the way they want to see it. And usually the established newspapers also cross-check with you. They would not publish it without your consent. At least that's what the journalistic integrity and ethics suggest. You also see that so like those two things. And in addition to that, just to quickly point out that the majority of scientists express their opinions in a fairly certain fashion with little hint of uncertainty. And often they made those predictions outside of the domain of expertise. By the way, there was no difference in terms of who was making predictions within or just observations based on whether they were expert or non-expert. Now, this results may not be surprising. Governments and general public often rely on experts and so contact them. And there's this general belief that experts, social scientists, including our tribe, make better judgments and predictions of the future. And the media seeks out experts to render their judgments and opinions about what what to expect in the future. And this has definitely been the case in the context of the pandemic. The idea behind it is that expertise in a particular subject matter gives you some kind of competitive edge in predicting societal change relative to non-experts. If I pick a random person from a street, they shouldn't be as competent or as accurate in their predictions compared to academics. So that is the premise, the very fundamental premise. But how accurate are such predictions? And even if you go beyond the off-the-cuff predictions that people make when the newspaper reporter contacts them, how accurate would you be even if, for instance, I give you data and you can analyze this data for this particular domain and you're making predictions as given domains? I would constrain the focus, I will give you time, you'll get in a group with other scholars, things that you would typically do as a scientist. How accurate would you be? Now, I was not so sure that people would be very accurate. And the reason I was not so sure is that the studies going to the classic work by Paul Neal and my colleague Phil Tetlock show that experts are often not better than simple statistical analytical models, such as linear regression, or non-experts when predicting one-off geopolitical events or making clinical judgments. So far, we don't know about the accuracy of social scientists, for instance, cross-cultural researchers, for predicting societal events. And maybe there are some claims that maybe it's easier to do that than some kind of one-off geopolitical events. Plus, in addition to that, maybe there is some benefit of social science training. After all, we have a lot of causal models that we focusing on explaining, providing mechanisms, trying to understand where cultural differences emerge, or why certain groups behave in one way versus another way, what happens if people isolate themselves, and so on, how all those features may be affecting our behavior and our communities. So we have a lot of causal models. In addition, social scientists arguably have some better understanding of statistics and probability theory and base rates. So maybe using that information, we'll be able to provide more accurate insights than just some lay person, and as well as people who are non-experts. So I was laying in bed in March 2020, and it occurred to me that now that I have all the time of my life to write papers and engage in all fun activities such as binge watching on the Expanse series, which I did then in April. I can also try to use the moment in history, namely those lockdowns and the changes that may be ahead, to examine how we are doing as a community, as an academic community, in predicting societal change, in predicting how a culture will unfold for particular psychologically interesting domains. So I organized the tournament. And we started with the tournament in June of 2020, where we gathered teams who submitted initial forecasts. And then it was very important for me to have an opportunity to update their forecast by getting some feedback to see whether it matters. And then in November, we expanded the focus and gave people an opportunity to update their initial forecasts, and also recruited some new teams. And so let's have a look what we found. But before that, let me tell you a little bit about the forecasters. Over 100 teams took part, providing over 700 individual predictions. Everybody had to provide at least predictions for at least one domain, which would be 12 predictions, so 12 months. There's some monthly markers. And forecasting teams came from all over the world, almost half from outside of North America. There were psychologists as a dominant group, of course, but not necessarily the only group. We had a sizable number of computer scientists, economists, members of the intelligence community taking part in the initiative. As such, this tournament ended up being fairly substantial, fairly comprehensive, probably the most comprehensive attempt to examine social science predictions of societal change and reasoning behind it. So one thing that was very important for me was also to examine what are the strategies that people are using. How do folks make predictions if they are asked to? So we'll get to that in a second. Let me tell you a little bit about the domains. Because we were interested in comparison of data to theory-driven forecasts, this has been an important factor in prior forecasting research. We restricted forecasts to domain for which we could identify large-scale monthly estimate prior data. So that's a pragmatic concern. Typically for data-driven forecasts, well, we need like about 30 data points to start even making any modeling projections. And therefore we focused on domains for which such data exists or where we could synthesize it. And these domains include well-being, political attitudes, as well as implicit and explicit prejudice. And by the way, these are the domains where we as psychologists and social scientists more broadly have theories how the pandemic may be impacting our behavior, be it either prejudice towards outgroups, or effects of isolation on our well-being, or increasing conservatism and certain attitudes towards people who are thinking differently about the president than you do in politics. For life satisfaction and affect, we could not use survey. Unfortunately, Gallup stopped collecting monthly data, which would have been otherwise a perfect survey pool in 2019. And only resumed after the pandemic started, which created a gap, a black hole for us. However, scholars, my friends at the University of Pennsylvania and Stanford have developed close approximations. And so with Lyle Unger's group, we used monthly Twitter data and combined natural language processing and machine learning techniques to estimate well-being and life satisfaction. By the way, all participating teams, forecasting teams, knew about where the data came from and what it was like for each of the domains, including the limitations and representativeness of the data. For political polarization, ideological preferences, we used weighted data from congressional generic ballot in the United States and from the presidential approval ratings from Gallup, sort of national representative surveys. And this is probably as good as it gets data for this particular domains. And by the way, political polarization here, as defined here, is different from the affective polarization. But there's work that showed that at least over the course of the pandemic, work by Jamie Druckmann and others, at least over the course of the pandemic, presidential approval rating differences by different political parties closely followed other polarization markers. And again, our participants knew about what the markers were, how they were calculated. And finally, for 6 domains concerning bias, implicit and explicit bias, we use data from Project Implicit. This is not representative data. And by the way, here, a huge kudos to Jordan Axt from McGill, who was kind enough to provide data ahead of official public release. This is very, very important for us so that we could give data back to our forecasting teams and provide them with an opportunity to update. And so for explicit bias, we used feeling thermometers, and for implicit bias, we used IAT scores. And I assume that for this crowd, I don't have to go into detail explaining this, because Project Implicit website is not a representative sample. It's like you would normally log in through the website, and we used a ranking procedure developed by the American National Election Survey and adjusted the scores on the national level by demographic characteristics and political orientation of the sample to approximate the United States populace at large. Let me show you an example what the forecasts looked like using the domain group of domains, the cluster of well-being, most teams took part in. So here, a large picture, you see negative affect, where average forecasts widely differed from the observed estimates over time. You see also in red the historical data, 2 last data points of the historical data on the left. Then you see a gap, and then the first forecast, and then in green, and I apologize for those of you who may be colorblind, but essentially you see this line with dots. Those are then the objective markers, ground truth markers, as computer scientists call it. And you see the individual forecasts of teams in the first tournament and in the second tournament. And you see the lowest curve approximating the general tendency across teams. So what do you see? Oh, first of all, you see that average forecasts widely differed from the observed estimates over time, whereas the ground truth markers show a substantial swing of over 1 standard deviation. So this is z-scores on the y-axis over the period of a year. You see this huge swing in the dotted line, in the line with dots. Average forecasts were much less volatile over the same time frame. And notably, both at the beginning of the first and the second tournament, the initial forecasts are in line with the ground truth and start to diverge over time. So like at the beginning, when you still have closer to the point where you still have the data, you're more accurate. The more you diverge from that, the less accurate you become. And you also see variability for positive affect. Again, this is z-scores. But you also see some reasonable degree of convergence when you look at the life satisfaction scores. Now, how would we estimate the accuracy here? How do we measure magnitude of accuracy? For a single domain, that's pretty easy. You just take the scores, you take the objective scores, the scores that were predicted, objective scores, calculate absolute difference, average those scores across 12 months, and there you have it. So you get this mean absolute error score. But when your domains are on different scales, you can't really do it, because otherwise you'll end up with peaches and oranges. Different scales, absolute differences don't work. And an elegant solution here is the scaled errors approach, or mean absolute scaled error, MAZE. So when you hear MAZE, when I say MAZE from now on, that's when I refer to this scaled errors. So first, you would train a mean absolute error, just like for the typical approach, from a simple forecast such as random walk. Now, random walk is a stochastic process. It's random. It assumes that past variables are successive, and then the next point will be random. So like you just take one step in the random direction, whether one point up or down, and then for the next prediction, you do the same thing. It has to be 1 point up or down. So there is a relationship to the prior data points. But where it goes, it's completely a chance. So there's nothing deterministic about it. Next, we would use the scores, which are on the same scale as the original forecast, to adjust the errors for each of the forecasts. So that's what you see on the top right here. On the top, you have the errors from the initial forecast relative to the objective markers. On the bottom, you have this scaled errors from the random walk procedure. And finally, we can then average those errors for each of the forecasting series. Now, one additional handy feature of the MAZE is that it immediately allows you to see if the forecast is better than the simple in-sample random walk. If the score is below 1, then your forecast is better because the errors are smaller than the random walk. If the score is above 1, then you're worse than the random walk. Okay, so that's what we'll get here. So let's take a look at those MAZE scores for different domains. And I think this will be quite insightful, because now we can also look at which domains were generally easier to forecast for scientists than others. So let's have a look on average. Here what you see is the ranking of domains from easiest, smallest number of errors to largest number of errors on the top. And you see that explicit gender career bias and positive affect and implicit gender career bias are easiest to forecast, smallest number of errors. You also see that African-American bias and Republican support were hardest to forecast. You also see some other things. Number one, see that some of the lines are solid, others are dashed. Solid line means that the change in accuracy between tournaments is statistically significant. It means that in the second tournament, in most of the domains, people did better than in the first tournament. Why is that? Well, partially we tested different possibilities, and it turns out it's because people had greater knowledge at tournament 2. It was not because they had to forecast smaller time series or some other alternatives. You also see that the domains with greatest volatility, greater variability in historical trends over time, were hardest to forecast. So those domains were negative sentiment and bias towards African Americans. And I can explain why there's greater volatility, but suffice to say is that, and this is a little anecdote, I did not initially even want to include African-American bias because I thought this is surely not going to be the domain. Now keep in mind, this was in early April 2020. This will not be the domain of great relevance to the pandemic. Of course, I was completely wrong, and I couldn't anticipate the subsequent Black Lives Matter movement that emerged after the horrible events in the early summer of 2020 in the United States. And so consequently, we have a number of things. And then I was thinking, thank God I included that domain. And we had some good data on it in the project Implicit. And because it has been so timely and so relevant for the current events. Okay. in addition to just looking at accuracy. Oh, by the way, well, I will get to that in a second, but one thing that you may want to notice too is, like I mentioned to you, that the scores below 1 are better than a random walk, and scores above 1 are worse. And you probably noticed that across both tournaments, most of the domains on average were below, above 1, sort of below the threshold for being better than a random walk model. And only one domain, explicit gender career bias, was on par with random walk in tournament 1, and all other domains where people made more errors. So that may give you already a clue that people potentially didn't do very well. I'll get to that in a second. So how do we evaluate expertise here? We can do it in the domain general way. We can look at the overall performance of social scientists against so-called naive benchmarks. By the way, this is something that has not been done very much for the forecasting teams that worked for different governments predicting the course of the pandemic. Often I don't know about your country, but in Canada, we didn't even use basic benchmarks to compare how our modeling experts have been doing. At the beginning, at least, we did. Typically in forecasting initiatives, we would do that. We would use some naive, very basic statistical methods to see if expertise provides some competitive edge. I already introduced random walk. We can do out of sample random walk. We can also take the historical mean of those 39 months. And we can also just use something that you're all very familiar with, because you probably use this method a lot in your approaches, namely linear regression. Okay, so we can look which of those 3 markers overall, how did they do, and then compare in accuracy to how scientists did. We can also look at relative performance compared to non-scientists. If I take a random, like a sort of representative sample of just some Americans, because we wanted to localize it again, this is predictions for the United States. By the way, let me emphasize for the cross-cultural researchers who may feel like, why again focus on this weird country? This was only for pragmatic reasons, that the high quality data that you need to make predictions is still not available for other societies to the same extent as in the United States. Now, since the pandemic, we started doing better. And I hope that we can do this type of initiatives in other parts of the world. But the truth is that historically, the type of monthly estimates, national estimates for social science relevant phenomena have not been collected and continue not being collected at scale that we need, at the level that we need to use. So I hope that that can motivate us. So go to your governments, try to convince them that we actually need this data because it can help us with modeling societal processes. So that's the only reason why we went for the United States data. Otherwise, I would have loved to use others. Okay, in addition to the domain general approach, we can also look at the domain-specific approach. So here I asked teams if anybody on their forecasting teams had a domain-related publications. Okay, let's take a look. What do we see here? We have 2 tournaments. These are the mean estimates from the linear mixed models. And you see that this dashed vertical line is at the point where we would expect scientists to do at least as well as this is estimates from prior forecasting tournaments. I will not go into much detail, but essentially there are forecasting initiatives in data sciences, and one of the most recent ones has used a large-scale heterogeneous data set from Walmart. So this is in the domain of business, about various types of forecasts. And data scientists have been making predictions. And what I did was I took the median score of their forecasting accuracy using their MACE score. So because this is an established metric, and this is what that red dotted line indicates. Okay, and you see most of our scientists didn't do as well as the data scientists. You also see that there is quite variability, not surprised, we already discussed that. You also see the naive crowd estimates, and you see the benchmark estimates. Now, in terms of naive statistical benchmarks, in the tournament 1, scientists did better in 2 out of 12 domains, and the naive one of the top 3 naive statistical estimates. I would just take whatever one of the 3 does better. In tournament 2, scientists did better in 5 out of 12 domains, but still in the majority of domains they did worse than either linear regression or the random walk. That's a problem. Or maybe not. And we can discuss that in discussion, because there's actually some evidence that historical mean is often very hard to beat for societal forecasts. Secondly, you may think that scientists did much better than the naive lay people. That's not necessarily the case. So we here look at the Bayesian approach, which allows us to see if there's evidential value in support of the null hypothesis or in support of the difference. And there is one Bayes factor strongly in support of the difference, 2 Bayes factors moderately in support of the difference, and then there's one Bayes factor moderately in support of no difference, and one strongly in support of no difference. So it's basically saying there's no difference between the average forecasts of scientists and average forecasts of lay people. And the rest were neither here nor there. 4 were anecdotal in support of null, 3 were anecdotal in support of the alternative. I suggest that overall, maybe you can cherry pick a domain that where you say, well, look, scientists are actually much better than lay people. Domain expertise matters, or expertise in social sciences matters. But I would say that across the board, not much of an evidence. We can discuss that again. Another interesting observation, I was interested in the method. What method did scientists use? What was the accuracy of this method? And we classified the methods based on the submissions that all scientific teams provided in terms of whether it was just purely data-driven, purely heuristic-oriented, using some intuition or some kind of psychological theory, but not relying on the data, or hybrid. By the way, one important caveat here is all teams were forced to review the historical data, because I asked them to download an Excel sheet on which historical data was plotted and put in the forecasts that they would make, regardless of the approach that they use, in that Excel sheet, which would automatically plot it. So they could actually still see some kind of continuation of a line. How does it fit to the prior historical trend? All that is done for them. They're forced to consider that. But nevertheless, how they did go about creating this forecast, that may have varied. And as you can see, in both tournaments, those who relied on heuristics didn't do as well as those who relied on prior data, even not considering any theory. Then in addition to that, we look at the contribution of specific forecasting strategies, number of parameters, statistical model complexity, consideration of exogenous events such as the pandemic in the first place, counterfactuals, team characteristics. And here they are ranked in terms of the magnitude of the contribution towards accuracy, from most positive to most negative. So for instance, replicating some prior work, statistical model complexity was inversely related to accuracy across domains. And there's also a similar trend for number of model parameters. So simpler forecasts, reasonably simpler forecasts were better than those that included a lot of factors and probably overfit the model. On the other hand, some forms of expertise did matter, even though the contribution, of course, was fairly modest. Number one, if there's somebody on the team who had participated in some forecasting initiatives, or if there's somebody on the team who has published on the topic. In contrast to that, the subjective confidence in the expertise of the team did not matter. As you can see here, that was not significantly different from 0 in terms of the magnitude of contribution to accuracy. And in fact, it goes in the opposite direction, suggesting that overconfidence or confidence in general can be inversely related to accuracy. And it was indeed, for life satisfaction, significantly negatively related to accuracy. So how can we move forward from this? Let's start with examining, once again, possible reasons for inaccuracy. In the real world, effects may be smaller than social scientists may think, based on their lab studies. And by studying social phenomena in isolation and implicitly assuming their independence, social scientists may underestimate the impact of phenomena on each other in the real world. So there's maybe both underestimation and overestimation of the magnitude of the effects when studied in isolation. That may have contributed to inaccuracy. Also, I mentioned this already before, there is potentially something about application on societal level versus individual level, and social scientist findings may just not scale up when applying to the societal level. Often we interpret individual phenomena as equal and isomorphic to societal, or cross-sectional data as isomorphic to dynamic processes of change, which is never a given. We also don't really train our students and ourselves in prediction. Many of us focus exclusively on explanation or mechanistic approaches to explaining or uncovering some phenomena. Few psychological models of societal change exist. We have little attention to ex-ante predictors, including for folks, for instance, who are part of the forecasting tournament. I had to explain why would ex-ante predictors differ from other type of out-of-sample predictions, like I did for you earlier. We have fairly little knowledge how to formalize predictions if we even try to make some quantitative predictions. And instead of that, we often have this unbiased preference for unbiased estimation of model parameters in the sample over the predictive out-of-sample accuracy, which results in this kind of Polaroid approach. And by the way, I do not want to bash on the estimation of model parameters. This is a totally legitimate philosophy of statistics and approach to science. I just say that it is incomplete, especially as many of us have been tempted and will continue to be tempted to make inferences about such things as cultural evolution and change. Overall, I think what we need to consider is that studying cultural change and modeling into the future matters. It matters because cultural change can act as a moderator. Shifts in frequency of expression of a phenomenon in a culture can lead to unreliability or low reliability of previously established cultural differences, which suggests that we may potentially need to routinely reevaluate established phenomena. Change in the nomological structure of a particular phenomenon over time, where the meaning of a term may change over time, presents even greater dangers and difficulty. And this is not something new. Psychological scientists have known and acknowledged these issues over time, but until now we still rarely study how cultures change, and we rarely consider how they may change in the future. So I want to finish by referring to the IACCP's the foundational, where Harry Seldon, that you see in this picture, combined psychology and mathematics to accurately predict societal change, including the decline and rise of civilizations. Right now, some of our colleagues say that we are at a time of decline and rise and reshaping of civilizations. Is this the time where we can at least try to be a little bit more like Asimov's psychohistorians? I'm not sure, but we can certainly do better. We can probe the limits of social science theories by evaluating if a given theory is suitable for making predictions in the first place, or if it's too narrow, too vague. We can learn the principles and understand the principles of temporal dynamics. Is the trend deterministic and hence can benefit from theory-driven components? Or does it unfold in a purely stochastic fashion? So we need to understand how to model properties of time series and tease them apart. And I think this is something that we need to incorporate in graduate training. Most of our departments around the world don't do that in social sciences yet, at least not to the extent and as systematically, and definitely not in cross-cultural psychology. And finally, we need to practice intellectual humility and recognize our limitations and not be afraid of them. We should not be afraid of making predictions and locking them in and evaluating if they were and why they were inaccurate, because that's the only way to build our models forward. Thank you so much for listening. I hope you enjoyed this presentation, and I'm looking forward to discussing this with you during the Q&A.